Today's video notes are Where Does the Matter Go? These will be posted on my YouTube site, so if you're absent or you need to go back and rewatch it, you can. The first thing is you have to understand that when chemical reactions take place, matter changes. It's called a chemical change, but it does not disappear or appear. The molecules and atoms just get rearranged and form new molecules and atoms. The matter is not lost, nor is it gained. Just new bonds are formed, and think of it as getting rearranged. And that's what the law of conservation of matters and energy says. It says that the total atoms of each element are equal on each side of the reaction. So we don't get rid of any, for example, hydrogen atoms or oxygen atoms when those two gases combine to make water. They just get rearranged. The law of conservation says that matter can neither be created nor destroyed. It can just change forms. So it gets rearranged. Now, we see chemical reactions taking place all the time. The acid in milk, lactic acid, and baking soda, which is a base, when you mix that together with flour and sugar and you put it in the oven, a cake bakes, carbon dioxide gas is formed, and the cake rises. So the carbon and the oxygen from those chemicals gets rearranged to produce that gas. When we burn paper, that paper, once it's set on fire and burns as a chemical reaction, it changes, and we have ashes, and we have carbon dioxide gas, and we have water vapor being released in that reaction. So the paper molecules get all rearranged. We did on Monday the comparing compounds lab, and you saw the hydrogen peroxide decomposing. Those bubbles that were rising was oxygen gas, and that remaining liquid was water. So everything just got rearranged. When we put the zinc in the hydrochloric acid, the zinc began to get rearranged, and there was a gray liquid left in the bottom, which was zinc chloride. We collected the hydrogen gas in a balloon. So you can see by that equation, we still have zinc on both sides of the equation, we still have hydrogen on both sides of the equation, and we still have chlorine on both sides of the equation. So the matter just gets rearranged in the reaction. So what you start with in the chemical equation are called the reactants. You can have one reactant, you can have multiple reactants. And the reactants, all their parts get rearranged and produce a product. Think about multiplication. The product is the answer. The error in a chemical equation is an equal sign. So the reactants must equal the products. So that tells me that the total number of atoms of each element has to be the same on both sides of the equation. And next week we will start counting those atoms and see if equations are balanced or not. Now, another thing you have to remember in a chemical equation is if the system is closed, then all the mass can be counted for on the product side of the equation. So if we do it in a sealed baggie or a sealed test tube or a flask with a stopper on the top, you can control, that's a controlled environment, and what your starting mass is going to equal your closing or ending mass. However, if you do it in an open test tube or an open flask or an open baggie, if any gases are formed, gases have very low densities and they will escape. You saw with the hydrogen peroxide and the yeast, it foamed, it rose and foamed over. Gases will escape. And there you might have some apparent mass lost, but it's not truly lost, it's just out into the atmosphere, into the air. So that would be an open system. Now, we're going to stop here today, and we're going to look at kind of the history of how scientists figured out the law of conservation, focusing on the Lavoisiers, and then we're going to look at some other ideas that go along with the law of conservation. And then our next new lesson will include putting it all together and looking at some equations and counting the atoms to see if they are in balance. And when I use the word imbalance, I'm talking about equality, or is it equal on both sides of that arrow in the chemical reaction. And you've got to remember that reactants are what you start with, and they have to equal the products, what you end up with.